Hey guys, I'm recording this video to show you guys the prototype in action. I'm going to try to make this a short video. So basically, I've been waiting on this one part for a few weeks. I got it about 2 weeks ago, put it on the breadboard. It's working just fine now, this prototype. It's on a breadboard. I've tested it with a motor. It works just fine. Unfortunately, I was hoping I could show it to you working with a motor connected to it, so you could see the motor spinning in both directions and all that, and even the PWM capabilities with a microcontroller. But I've moved. I haven't been home for a week, and I won't be for a while. And I couldn't bring the motor with me. Wish I had, but I did bring my power supply, which doesn't make sense. But anyways. So I won't be able to show the motor connected to you guys, but let me just go through this prototype really quick. You can see these three ICs up here, one here, one there, and another one right there. What they are, those are actually the logic protection layers that I've been talking about. So one of them is a 2 to 4 decoder, one of them is a NAND gate, and the other is a inverter. So you can find all this in the design drawings that I shared a few weeks back. It's the same design. This is the implementation, so nothing has changed. And it works just fine, really. The logic protection layer basically makes sure that no wrong combination of transistors are ever turned on, because the results could be catastrophic if that were to happen. So this makes sure that never happens. So 12 volts supplied right here, and you can see right here is a 5 volt regulator. I don't know how well you can see it, and these ICs up here, they run at 5 volt logic, and as you know, the C2000 it runs at 3.3 volts logic, which isn't 5, but the decoder I have, 3.3 is good enough to count as a high, so it works just fine. I've tested it, and you can see these giant caps. They're temporary, they're gonna go. That's just overkill. But then this is what this whole project's about. But anyways, and then you can see these beautiful transistors I have down here. There are 8 transistors. I spent quite a lot of money on these transistors. They weren't that cheap, unfortunately, but they do the job. They're great transistors. They're good for this project. They're pretty beefy, and so this is the H-bridge really down here. So technically you don't really need the logic layer up here, but I'm just being safe here with the logic layer. I could technically use the microcontroller to directly control these transistors, but if the microcontroller were to crash, if the GPIOs were floating, you could have these transistors in bad states, which could cause big damage to everything, really. So that's all safe. Like I said, I wish I had the motor with me. I've actually tested it with the C2000, providing a PWM signal to the inputs. Speaking of which, these are the 2 inputs. They're kind of tied down to my demo rig here that I'm going to use in a second. That's just a switch right here to toggle them from low to high. Kind of simulating a microcontroller, but PWM does work in both directions. I've tested it. Wish I could show you guys, but alright, let me just show you guys this test rig that I have set up here. So I don't have the motor, but I do have 2 LEDs here, and LED, which stands for light emitting diodes, because it's a diode, it'll let the current run through it in only one direction. So I have 2 LEDs here connected in parallel, but one of them is the opposite, is connected the opposite as the other. So basically, when the current's running in one direction, one of the LEDs is going to light up, and when the current's running in the other direction, the other LED is going to light up. So that's how we're going to know if this motor control is working, because this is the whole point of a motor controller. Remember, we want to be able to run the motor in both directions. And on top of that, this can also do motor braking, which shorts the terminals. So if I had a multimeter or like a continuity test hooked up to it, we'd be able to see how well the motor brake works, but we won't be able to do it. So basically, neutral and motor brake will both make the LEDs turn off, which I think it's in one of those states right now. I don't even know. So it's 1-1. They're both on, both 1 and 8, that's where the two inputs are connected, so that's motor brake, and you can see they're not on. Same would go for when these are both off. You can see they're still both off because it's 0, 0, so that's motor brake. Alright, let's run the current in one direction, so I'm just going to flip one of these high so the other one is still low. So I don't know how well you can see, but the green LED is on. Yeah, you can, if you look at the green LED, I'm toggling it. So that's on, and let me now run the current in the other direction. Hard to see. I swear the red LED is on. Just look closely, it's there. Trust me. So, anyways, it works. It's kind of a lame demo, unfortunately. I really wish I could have the motor connected and run the demo that way, but oh well. Sorry if I shook the camera too much, but hope you enjoyed. Do leave comments, please. Thank you.